Welcome back to AWS On Air. This is a special live segment of Under the Hood with AWS. And joining me today is Arvind, Raghu, and Farah. I think everybody probably knows Farah from the last segment as well. So Arvind, why don't you introduce yourself here?
Sure. Hello, everybody. My name is Arvind. I'm a principal specialist at AWS responsible for the confidential computing business. That typically means I focus on the Nitro system, Nitro enclaves, Nitro TPM, and other confidential compute capabilities such as AMD, CVS, and P.
All right. So that's a lot of stuff there.
It is a lot of stuff, and I'm like, so it's not confidential as we can't talk about it to others, you know.
Right.
No, it's confidential from a data perspective. It's confidential from protecting customers' data. That's what it is.
So I think maybe we should define what AWS means by confidential computing. So maybe you can help define that a little bit here.
Absolutely, I will. So at AWS, we define confidential computing as the use of specialized hardware and associated firmware to protect customer data while it's in use from any unauthorized access. So the key to focus on here is protecting data while it's in use. The mechanisms to protect data while it's at rest and in transit have existed for a while. We are extending that protection to protecting data while it's being processed. So that's what confidential computing is about.
Which, Farah, obviously most customers really care about, like making sure their data is protected while an operation or while they're doing something is happening here.
I mean, I care about that in any system that I'm using, in any application I'm using, I care about my data as well.
Yeah, it's really extending that protection end to end. You know, it existed when the life cycle of data begins. You do three things with data: you store it, you move it, you process it, right? So storing and moving it have been there. Now we're just extending that into the processing realm.
So I thought earlier today during the keynote, CJ was talking about the AWS Nitro system and some of the confidential computing elements that have been built into that system. Maybe we could talk a little bit briefly about that Nitro system and how it drives our confidential computing story.
Absolutely. So to understand confidential computing, we need to first understand the different dimensions that customers are most concerned about when they talk about confidential computing. And when I say dimensions, it's really about who are they protecting the data from, right? So we always ask customers when they talk to us, who are you looking to protect your data from? Dimension one is where they're looking to protect their content, code, and data from operators on the cloud provider side. In this case, it's us, AWS.
Yeah, of course, right?
Yeah. And then
well, it's a logical thing, right?
Yeah, of course.
Right? You don't want us to see yourself, right?
No, I'll be honest. I actually I would have assumed it would have been like attackers or like hackers first. I wouldn't have thought about it from the cloud side. But yes, it's a very good point.
It's a little bit more fundamental than that, right? And this is what we tell our customers. Your data, the way we look at it, is radioactive to us. We don't want to touch it. We don't want to go near it. We don't want to see it, right? So that's really dimension one. And dimension two is where they want to extend that protection and even protect it from users at their end, from themselves, or malicious actors, as you said, who could pose as admin level users at their end. So the two dimensions, protection from us and protection from themselves. And Nitro system holistically has capabilities to address both of these. But fundamentally, intrinsically, the Nitro system is built in such a way that customers get protection by default from any AWS operator to be able to access their content. So that's fundamental, right? That's default confidential computing when you use a Nitro-based instance with AWS.
Yeah, and I think one of the things that CJ talked about today or introduced was, part of our goal about security has been to increase the level of transparency that we have, right? Last year, Matt Garman talked about this in his digital sovereignty blog. And one of the things we've tried to do is be more transparent with you customers about how we are able to live up to that mission of doing security and making sure that we don't allow operator access or AWS access to anybody's data whatsoever. So I think one of the other things that we announced earlier this year that CJ spoke about during the keynote today was that we have now taken this to another level where we actually have worked with a third party, Farah, to verify our access, verify our architecture specifically, so that the architecture, when we say that there is no access from an AWS employee to your data or to a customer data in particular, that it is real. And we have verified that, trust but verify, I think is a statement people use elsewhere, right? So I think the announcement was about our validation that we work with a company. Why don't you talk a little bit more about it?
Yeah,
Arvind?
sure. So we engaged with NCC Group to validate the security design of the Nitro system. And we have claimed that there's no operator access to any of our customer content in the past, right? So this report actually goes in, validates that, it finds that there are no gaps in the security claims that we have made with the design of the Nitro system. So that's what this report talks about. At a very high level, if I have to, put the different claims in different buckets, number one, this report validates that by design, there's just no mechanism for any AWS operator to log into a Nitro host. Number two, there's no mechanism for any AWS operator to access customer content. That's both code and data. Number three, there's no mechanism in place for any AWS operator to deploy code into a customer's Nitro host. And number four, none of the administrative APIs can actually be used on any of these hosts without proper authentication and approval. And every access is logged, and there's a trail behind all of this. So that's really what the claims have been about. The report went in, looked at the design, evaluated it, and has found no gaps in any of the claims that we have made in these areas.
So, Farah, to your concern about your own data within us, at least this helps us ensure that no data and no access from any AWS employee. So if you put anything into the cloud, none of us have the ability to take a look at it.
That's right.
Right?
That's right.
And
so Big Brother's not watching.
No.
I'm just saying.
Right. Well, and the other thing that I think that Arvind only briefly touched on is another key element is that, part of the Nitro system architecture is that even if you are doing an operation within the cloud, we also have restrictions on preventing you from potentially updating the software in the cloud as well that impacts other people. You can upgrade software within the workload that you're operating in the space that you have open, but you cannot. The design that we have where the Nitro system and the cards are separate from the instances that are being operated on means that customers can't actually create problems for other customers. We are able to do that validation, right? So every time before an updates are done, that is a controlled environment as well, another level of security that exists.
That's right. Customers, so the way the Nitro system is built, there's actually physical isolation between the actual Nitro system and the customer instances. Customers don't have access to anything that's running in the backend in the Nitro system. So hypothetically, in that case you talked about, if a malicious user was trying to muck around with any of the BIOSes or any of the spy interfaces that's sitting in the Nitro system, there's just no way to do it because of the design of the Nitro system, where there's a Nitro controller card that's sitting in between the customer instances and our Nitro system itself. And there's a very controlled, secure, measured boot process that tracks every piece of firmware that needs to be in place to an expected state prior to a boot itself. So if anything has been tampered, the boot just won't even happen.
Exactly.
Right?
And so this goes a little bit back to Farah's earlier thing, saying, well, I thought that the first thing might be from a malicious actor. So this is one step to prevent potential, quote, malicious actor. Not that a customer is necessarily a malicious actor. Most things happen via error, frankly. Everybody's done an update, especially when I was doing software code, right? You can make a mistake. So I think one of the other things maybe we should briefly talk about here is some new features that we have launched in the past couple of months here. After all, here we are at Inforce, and we're announcing new features. So maybe the first one we can touch on is AMD SEV SNP.
Is this your favorite one? Is this your favorite?
I don't know. This is my favorite.
It's the latest, though.
It's the latest. It's the latest. Yeah. I would say favorite.
Our favorite is always customers, so that's our favorite. Our customers are our favorite. But AMD SEV SNP is a CPU-based capability that addresses some of the needs that customers have in the confidential computing space. So it provides memory encryption, and it also provides a mechanism to attest to the actual CPU that's running in the host. So it has mechanisms in place through which it provides measurements that customers can then use as part of attestation to establish trust between the instance they're running and whatever else other entity that they're trying to interact with, so they can then start sharing data. I do want to point out that we have these capabilities through other mechanisms as well. So for customers who are specifically asking for CPU-based capabilities, AMD SEV plays right into that kind of use case.
Yeah, and just a couple of notes just about AMD as well. For those out there, this is capability obviously associated with them. Amazon has worked closely with AMD. We've also worked closely with Intel. And just as a note, since it's kind of breaking news just a little bit earlier, Amazon also participated in AMD's Genoa launch today and announced the preview for M7A earlier today. I know it's not precisely a security thing, but a lot of people are looking for that next generation and when things are happening. So I just want to kind of give that information out there to folks as well. So we talked about AMD Sev SMP. We talked a little bit earlier, we spoke about the Nitro system and the multiple dimensions. And I think the other secondary dimension that we talked about, or you briefly referenced, was protection of content from within. So, a lot of times, theft and other things can occur within an organization, or not everybody needs access to information within a company, right? Not all access, particularly, let's say, customer personal information, right, for example.
Right.
So one way we've developed to do that is something we call Nitro Enclaves. So maybe, Arvind, talk a little bit about Nitro Enclaves here
Sure.
a little bit.
Sure. So, like you mentioned, Art, not all data is created equal, right? So there's some data that needs to be treated a little bit more care, with a little bit more isolation, if you will, right? So there's innocuous data and then there's sensitive data. So if customer has use cases where they're processing sensitive data and they want to protect the data even from themselves, that's really when you look at a solution like Nitro Enclaves, which provides additional isolation on top of what the Nitro system already provides, right? And with that isolation, they're able to carve out a separate environment within which they can process the sensitive data more securely, and pretty much box it out of anybody's access. That's really what happens in an enclave. So you carve out this environment from your own EC2 instance. You dedicate CPU and memory resources, and what we do with an enclave is we cut out all of the external network connectivity. There's no persistent storage, nothing. So everything is happening in memory. And when you're done with the processing, you can terminate the enclave, and all of the data just evaporates. It's ephemeral, pretty much.
Yeah.
So that's really what Enclaves provides you with, additional isolation.
So earlier this year, we expanded those capabilities. So we didn't just have, we launched Nitro Enclaves a little while ago, but earlier this year in 2023, we launched multiple enclaves. So now customers can spin up multiple enclaves at a time. Do you want to maybe say how customers would use those multiple enclaves?
Yeah, absolutely. So now customers have the ability to spin up to 4 enclaves per EC2 instance. You can think about multiple different use cases here, but the easiest one to help people understand, you can have multiple different microservices, if you will, each residing within an enclave that are all attached to the same EC2 instance, which could all maybe passing on information to each other through the parent instance, but can all be running in one host. So that's just one way to do it. Another popular use case, if you will, which we followed up with, Art, by the way, after announcing the multiple enclaves, is Kubernetes support, right?
Okay, so that was going to be my question. I was like, any other compute services other than EC2 is supported?
Yes. So we did launch support for both self-managed Kubernetes and EKS. So now you could actually run multiple instances and also multiple enclaves within the same instance, and all of this can be managed with Kubernetes, right? So we launched support for that as well. So that's another popular use case, I would say, for something like this.
I mean, I think it's pretty exciting to be able that now that we're going to be able to support Kubernetes as well, and so both managed services and the EC2 services as well here. So I think we're getting close, actually, to running out of time for today's session. We'll actually be here again tomorrow for another Under the Hood session as well. But Arvind, thanks for joining us. And are there any other things that we haven't covered related to the Nitro Enclaves or confidential compute that you want to get out there now?
No, there's just a lot of use cases out there. But most importantly, when people are thinking about confidential computing or using a feature like enclaves, I would highly encourage you to think about what is it that you're protecting, who are you protecting it from, and all of the features that you're going to use will derive from that specific need. So not everybody needs something like enclaves. So think carefully as you make your choices. Some of it is already fulfilled by default with EC2 Nitro-based instances.
I think that's a great way to end. Is just like, not every element of security is needed by everybody, but security is super important, and that's why we provide a certain baseline to customers as well.
Absolutely.
So, yeah. Thank you for joining us today, and Farah, as always.
Yes,
nice
thanks for having me. Yes.
Yeah, absolutely.
Thanks, Art.